Hello students, welcome to EPG Pathshala. I am Dr. Ranjit Singh from the Energy and Resources Institute, New Delhi. Today we are going to talk on module conversion of sugar to alcohol, that is called Gasohol, under the paper Environmental Biotechnology. After completing this module, you should be able to understand about Gasohol, feedstock for the bioethanol production, bioethanol as a fuel, and advantages and the concerns of the manufacturing of ethanol. Let's first talk about gasohol. What is gasohol? So gasohol is an alternative fuel. It is a blend of 10% ethanol and 90% unleaded gasoline, which is called petrol. The gasohol is gaining wide acceptance as alternative fuel for motor vehicles or as energy source from biological sources. Gasohol has been approved for use in several countries and can be used without any modifications in the vehicle's engine, and it releases the same amount of energy as the regular petrol. Gasohol is useful in decreasing the population's dependence on foreign oil and reduces the carbon monoxide emissions by up to 30%. It is comparable in performance to 100% unleaded gasoline with the added benefits of superior anti-knock properties. Gasohol containing ethanol normally has an E value or E number, which explains the mixture. For example, let's take E10. E10 means this gasohol is consist of 10% of ethanol and 90% of gasoline. How gasohol is prepared? In gasohol preparation process, gasohol production is achieved by microbial fermentation process. In this process, yeast, bacteria, that these microorganisms convert sugar from plant biomass, for example sugarcane, corn, grain crops, into ethanol, and this process is called alcoholic fermentation. The gasohol preparation process is now very much increasing in demand worldwide due to continuous depletion of fossil fuels, economic and political crisis, and growing concern on environmental safety. So in this preparation process, mainly three types of raw materials are utilized for this purpose. For example, sugarcane crops, starchy crops, and lignocellulosic materials. The plant materials are chemically treated to break down the cellulose. The end product of the breakdowns are sugar, which can be anaerobically fermented by microorganisms to produce ethanol. One of the widely used alternative automotive fuel in the world, Brazil and USA are the largest ethanol producers of gasohol. So why we have chosen ethanol for the gasohol purpose out of the other alcohols available? So we have chosen ethanol because ethanol is very fuel efficient molecule. When ethanol is mixed with unleaded gasoline, it increases octane levels of the fuel, it improves combustion of the fuel, and ethanol extends the supply of gasoline. Therefore, the use of gasohol improves the octane number and combustion efficiency. The second important point of using the ethanol is it's a very eco-friendly, as ethanol is a renewable sources of energy. Its production or the combustion does not emit greenhouse gases or poisonous pollutants. Also, use of ethanol reduces the emission of particulate matter and sulfur dioxide. It decreases the discharge of benzene and butadiene in the environment that causes cancer by 50%. Use of ethanol decreases the emission of hydrocarbons that deplete the ozone layer. And most important, the most common blends contain 10% ethanol and 85% ethanol mixed with gasoline. Then how ethanol is produced for gasohol? Ethanol is also called ethyl alcohol, grain alcohol. Ethanol is a clear, colorless liquid with a characteristic odor. Process of ethanol manufacturing has been made since ancient times by the fermentation of sugars. All beverage ethanol are more than half of industrial ethanol is still made by this process. But the beverage ethanols contain some impurities so that it can be consumed as such. Simple sugars are the raw material for ethanol production. Sugar to ethanol conversion is a fermentative process which is also referred to as ethanol fermentation. The fermentation is a biological process in which sugars such as glucose, fructose, sucrose are converted into cellular energy in the form of ATP and thereby produces ethanol as a byproduct and carbon dioxide as a metabolic waste products. The ethanol fermentation process is an anaerobic process which is performed by several microorganisms in the absence of oxygen. The below diagram is a conversion mechanism of ethanol conversion process in which one molecule of sucrose or glucose is utilized and converted into two molecules of ethyl alcohol and two molecules of carbon dioxide. Plus, it generates energy in the form of ATP, which gets stored inside the organisms as cellular energy. And this conversion process is mediated by an enzyme, gymase, which is particularly found in the yeast. In fermentation, ethanol retains much of the energy that was previously captured in the form of sugar during photosynthesis. That's why these ethanols contains or ethanol have an excellent fuel. But there are some challenges associated with ethanol as a fuel. The first challenge is the cost of production. The cost of production of ethanol is very high than the cost of producing fuels from the petroleum. Moreover, a lot of plant material is needed to produce the ethanol, leaving lots of cellular waste. This leads to the deforestation that was due to to make more use of the forest material and land for the cultivation of the plants. The car engines need some special modifications that will enable them to use pure ethanol as a fuel. The other challenges is continued progress with both conventional and advanced ethanol production technologies could someday result in ethanol production cost competitive with the available petroleum fuels. There is also ethical issue associated with uses of ethanol as a fuel, as using plants to produce fuel instead of feeding the hungry. That is a main concern for the use of large scale use of ethanol as a fuels. So what are the raw materials for the manufacturing of bioethanol? So almost any part of the plant can be served as a feedstock for ethanol manufacturers, but the choice of raw material depends on several factors. For example, the ease of processing of the various plants available in that particular region, the prevailing conditions of the climate, landscape and soil compositions, and sugar content of the plant material. So ethanol can be produced from either sugary material, starchy materials and cellulosic materials. All these materials have enzymatic hydrolysis process which breaks down the biomass cellulosic portion into sugar solutions, which will then converted into the ethanol through fermentations process. So as we discussed earlier, bioethanol, there are main three raw materials for bioethanol productions: the sugary material, starchy materials and lignocellulosic materials. The sugary materials are sugar canes in the form of sugarcane molasses and sugarcane juice, sugar beets, sweet sugar, wheat, sorghum, whey, or simple sugars like glucose, sucrose and lactose. The starchy materials include cereals, which is wheat, maize, barley, sorghum, corn and rice, and roots of potatoes and tropica. The lignocellulosic materials include wood, paper waste, agricultural waste, and other lignocellulosic waste. So now we will discuss about the fermentation media and the condition of fermentations. So in media, the first requirement is the nutrients. So in the nutrients, the carbon source would be pure or crude sugars or molasses in the 5 to 10% of concentration and starch. The nitrogen source could be corn steep liquor, soybean meal, pure ammonia or ammonium salts, urea, nitrate salts or phosphate salts. These are the cheap source of nitrogen source for the fermentations. We will also require vitamins and growth factors like minerals, biotin, yeast extract, beef extract, etc. And the pH and temperature of the fermentation conditions. The pH should be around 4.8 to 5% and the temperature will be in between 25 degrees centigrade to 30 degrees centigrade. And the time of fermentations. The time or incubation time of fermentation depends on the microbial strain. Generally, the fermentation time requires 3 days to complete the process. Catalyst. For these fermentation reactions, the catalyst would be either whole microorganisms or as a purified enzymes that will convert the simple sugars into the ethyl alcohol. What are the organisms used for fermentations? Mainly bacteria and yeast are utilized in the fermentation process. In bacteria, Gymomonas mobilis, Clostridium, Acetobacillicum, Klebsiella are used. In yeast, Saccharomyces are the most famous used organisms for the bioethanol productions. In bioethanol productions, inside the cell, glucose molecules are converted into 2 molecules of pyruvate, where this pyruvate is break down into 2 molecules of ethanol, and in this process 2 molecules of carbon dioxide are released and ATP are formed in the form of cellular energy. So let's understand alcoholic fermentation. So in alcoholic fermentation, ethanol is produced by carrying out the mainly 3 steps. The first step is the pre-treatment and enzymatic hydrolysis of plant biomass. In this process, complex carbohydrates are broken down into simple sugars by the action of different carbohydrate enzymes, which results in a mixture of 5 carbon and 6 carbon sugars. In this process, many microorganisms, particularly yeast, ferment glucose to ethanol. However, it is found that 25 to 30% of the sugar derived from cellulosic feedstocks such as sugar woods and other woody materials are pentose sugars that have 5 carbon atoms rather than 6 carbon atoms. The second step is saccharification steps. In this step, cellulosic polymers are broken down into 5 carbons and 6 carbon sugars through hydrolysis process. And for example, xylose and glucose are the 5 carbon and 6 carbon sugars, and the enzymes used are called cellulitic enzymes. And the final step is the fermentation. In this step, fermentative microorganisms such as bacteria and yeast are added to grow anaerobically, which produces ethanol and CO2 as the byproducts. Pre-treatment to disrupt the physical structure of plant biomass. In the pre-treatment process, the biomass is first treated with dilute acid or alkali that degrade the physical structural component of the plant biomass. As we discussed earlier, the plant biomass consists of, there are 3 main factors or components in the plant biomass: cellulose, hemicellulose and lignin. So during the pre-treatment process, these lignins, hemicellulose and cellulose are break down into smaller components, and after pre-treatment, enzymatic hydrolysis was carried out. In enzymatic hydrolysis, enzymes get accessible to the inside of the molecular structure of the plant biomass and degrade the complex polysaccharide into simple sugars. The other potential sources of biomass are soft woods, which have a lower proportion of hemicellulose and hence they have fewer pentose sugars. The pentose sugars are not readily fermented to ethanol. So yeast or bacteria that have been genetically modified to ferment both hexoses or 6 carbon sugars and pentoses are needed to maximize the yield of ethanol from cellulosic materials. Some researchers have been successful in engineering microorganisms that are able to use pentose efficiently, but it cannot do so naturally to produce ethanols. So this is the conversion of cellulose, hemicellulose and lignin into ethanol. After pre-treatment, cellulose gets converted into glucose or hemicellulose gets converted into xylose, and this glucose and xylose are converted into ethanol with the through microbial fermentation process. However, lignin remains undigestible and it's not available for the conversion process. This is the ethanol production from biomass. In the ethanol production, biomass is first pre-treated to simpler structures, which leads to solubilization of hemicellulose, and then after fermentation happens. In the fermentation, enzymatic hydrolysis leads to conversion of cellulose to sugars, as we discussed earlier, and then fermentations, conversion of sugar to ethanol. And after this fermentation, ethanols are produced, and this ethanol, after distillation and evaporations, gets converted into a purer form of ethanol. And the distillates were filter washed and then sent to the waste management process, where the wastes are converted into residues to powder production for other purposes, and the remaining part is recirculated through the process streams, and the lignins are discarded back as it doesn't contain any fermentative value. Again, this is the manufacturing process for ethanol productions. Here we have taken as an example of corn. The corn is first harvested from the field, and this corn is converted into mass through milling process, so that the enzymatic digestion of the mashed corn are very convenient. And after mashing process, this leads to the in a bioreactor where fermentation happened. After fermentation, the ethanols are distilled and dehydrated, and then it leads to the goes to the storage tank for further storage and transportation. Now the final step is product recovery. In product recovery, distillations are used. In the distillation process, a mixture of liquids or oils are generally used, and this distillation is relies on differences in the boiling points of the component liquid to be separated out. In ethanol distillation process, ethanol solutions from the fermentation step is distilled to produce up to 95% pure alcohol. This also goes through the process of fractional distillation process, in which ethanol has a lower boiling points than sugar than water. Therefore, ethanol will be converted into the vapor state first, which gets condensed and separated from water. The remaining distillate contains 95% ethyl alcohol and 4.4% water approximately. Through this process, the byproducts are generated, and the byproducts are the carbon dioxide, yeast biomass, and distillery effluents. The carbon dioxide are used for the production of dry ice, and pure form used for the preparation of soft drinks, whereas yeast biomass are used as animal fodder, which contains high proteins and vitamins, and the distillery effluents are used as a fertilizer and animal feed. So what are the uses of ethanol? First, ethanol are used as a fuel in an automotive fuel by itself, and the ethanol can be mixed with gasoline or petrol to form what has been called gasohol or fuel ethanol. There are other uses of ethanol in industries, such as it can be used as a solvents, as alcohols have applications in industries and science as reagents of solvents, as a solvent in medical drugs, perfumes, and vegetable essence. It is used in alcoholic beverages as an antifreeze agent, as an antiseptic to disinfect the skin, in the thermometer as a solvent, and it as a raw material in various industrial processes. Then how ethanol is being used as a transportation fuel? Most ethanol used for fuel is being blended into gasoline at concentration of 5 to 10%. All petrol engine can utilize the blended ethanol and needs no alterations. Ethanol is used as an automotive fuel by itself or in the form of gasohol. But there is a small but growing market for E85 fuel, which is 85% ethanol and 15% gasoline, for use in flexible fuel vehicles. These vehicles are flexible in the uses of fuel. Either it can use pure gasoline or mixed gasolines, so they have a choice of using both the fuels, several millions of which have been produced by US automakers. Countries using gasohol. Ethanol blends are used in the following countries and their formulations. In India, ethanol is used as a 5% blended form. The use of alcohol as liquid fuel is fairly in operation in several countries. This renewable resource of energy could partially substitute petroleum products, making a case of possible replacement of petroleum. The Brazilians are using a gasohol for automobiles, railways, and other heavy energy needed industries. In 1980s, USA commercialized the gasohol where 20% alcohol added to petrol. Now at about many service stations, gasohol is commercially available. So what are the common blends of gasohol? Generally, E5 to E25 are known as low ethanol blends, whereas E30 to E85 are considered as high ethanol blends. The most popular gasohol blend is E10, which consists of 10% of ethanol and 90% of unleaded gasoline. This is due to the fact that no modifications are needed to a vehicle's engine if you are using E10 fuel. So bioethanol has many applications in different countries, in different formulations, in different vehicles. For example, in FFV cars, it can use up to E85 formulations. In modified petrol buses, it can goes up to E100 formulations. In modified diesel buses, it can reach up to 95. Similarly, E5, E10, E15 have their own applications in different vehicles engines. So what are the advantages of gasohol? So it has several benefits over regular gasoline because it's a unique blend with ethanol. The first advantage is it's cheaper. We can save money per liter using gasohol instead of regular gasoline. The gasohol is greener compared to regular gasoline. Gasohol emits less carbon dioxide gas, benzene, butadiene and other toxic gases. Hence, it's better for the world and your health. The gasohols is a cleaner energy. Aside from being cleaner for the environment, gasohol also helps to keep car engines cleaned by reducing buildup of residues in the fuel system. The gasohol has higher performance. Since the ethanol is in gasohol raises the octane level, as we discussed, gasohol has higher performance than regular gasoline at the same octane rating. Hence, it reduces engine knocking and your car will run more smoothly. It's local. Gasohol can be produced in any region and thus reduces need for crude oil. Also, it creates economic growth in the agricultural sector and related industries. Gasohol doesn't need freeze. The ethanol in gasohol also prevents the fuel from freezing in the fuel system. So what are the scenario for ethanol production in India? So we will discuss in our later slides. India has initiated the use of ethanol as an automotive fuel. A move has been made by distilleries in India to use surplus ethanol as a blending agent or an oxygenate in gasoil. Currently, the mandate is for 5% blending, but if you go to 10%, one could save foreign exchange which is currently being used for to import crude. But the actual scene is ethanol blending with petrol yet to gather steams. At national level, instead of 5% blending of ethanol, we have achieved only 2 to 2.5% of blending of ethanol in the gasoline. Some 7 years have passed since the government launched the program to blend 5% ethanol with petrol. However, the desired blending has not yet been achieved because of problems over pricing, procurement and other social issues. In India, the country oil marketing companies or petroleum companies are purchasing millions liters of ethanol from sugar mills, making this to reach the country will reach its E5 blending target. The ethanol will reduce the country's $1 billion annual fuel import expenditures. Further, the country imports 80% of its fuel, but it is mandated to blend 20% ethanol by 2017. However, India imports nearly 70% of annual crude petroleum requirement, which is approximately 100 million tons. Therefore, the prices are in the range of 50 to $70 per barrel, and the expenditure on crude purchase is in the range of rupees 1600 billion per year, which is impacting in a big way the country's foreign exchange reserves. Now, the petroleum industry are very committed to use of ethanol as fuels, as it is expected to benefit sugarcane farmers as well as the oil industry in the long run. Ethanol can also be produced from wheat, corn, sweet, sorghum, etc. In India, government has recommended the use of E5, and Society for Indian Automobile Manufacturers or SIAM has accepted the use of 5% ethanol doped petrol in vehicles. India has also signed a memorandum of understanding with Brazil in April 2002 for transfer of technology in the fields of blending ethanol with petrol and diesel at higher proportions. Brazil is the only country in the world to have successfully adopted 100% sugar-based ethanol as fuel for automobiles. The current Brazilian legislation mandates blending of ethanol in gasoline in the range of 24 to 26%. Also in the USA, blending of ethanol in gasoline is done on environmental considerations. Ethanol blending is 10% in gasoline for cities requiring control on carbon monoxide emissions during winter months. The USA provide tax break of about 0.54% dollar per gallon, about rupees 6 per liter, to promote ethanol blending in gasohol. So now we will discuss about what are the social impacts of using gasohol as a fuel. The predominant social and economic impacts of gasohol productions are: first, the potential for new on-farm and other rural employment opportunities, and the possibilities of conflicts between food and energy uses of cropland. The pace of development and the quality of ethanol produced will be critical determinant of the social impacts. For example, if you demand for fuel ethanol increase beyond the supply of feedstocks, it can have effect on our social ethanol and in food crops demand. The other impacts are competition between energy and food uses of land that could result in more rapidly rising food prices and eventually more rapidly rising land prices. Specifically, low and middle income group would bear the greatest share of these costs, although farming groups have supported gasohol initiatives in the hope that increased demand for corn would raise prices. If the demand for gasohol rises gradually and market imbalances are avoided, the overall social and economic impacts of fuel ethanol production could be strongly positive. Now we'll talk about some recent headlines concerning to gasohol. Indian edible oil company plans to set up corn-based ethanol. In India, Rasoya Proteins plans to invest $81 million in setting up additional soya oil production as well as a corn-based ethanol plant. The company believes that increased demand for ethanol for blending will provide a market to support the new investments and opportunities. The interministerial group has agreed to change the formula used to calculate the price sugar mills get for their ethanol. It means that they will receive between 1 and 5 rupees per liter more during the next tender to supply from the crush starting in October. The sugarcane mills have been holding back from participating in the tenders because it wasn't financially viable at the prices the oil marketing companies were offering. Now we will discuss a case study of uses of gasohol in Brazil. In Brazil, use of 5% alcohol in petrol was made compulsory in 1931. Thereafter, blending of alcohol with petrol to be used as transport fuels started after the oil crisis in 1973. In 1985, Brazil has launched a program of using gasohol mixture of 75 to 80% inferior grade gasoline and 20 to 25% ethanol, and through this process they have saved 40% of its petrol consumption. Hence, Brazil is the first to produce the cheapest ethanol in the world. So, why we have chosen Brazil for our case studies, and why Brazil is so much successful in the production of ethanol? Because Brazil have favorable sugarcane cultivation conditions. Brazil have traditions of culturing sugarcane being the most efficient raw materials for the production of ethanol there. Now we will discuss about some facts about Brazil and the uses of gasohol. Brazil is the second largest producer of ethanol in the world. About 20 billion liters of ethanols are produced in Brazil, out of which 45% of Brazilian vehicles uses ethanol as fuel, where feedstocks are sugarcane bagasse and straw, which are rich in cellulose and turning entire sugarcane biomass into the ethanol with producing no wastage. For example, 1 ton of bagasse produces 186 liters of ethanol in Brazil and on average. The below is a ethanol car production in Brazil. If you see this graph from 2003 to 2007, there is a significant increase in the production of ethanol car in Brazil. The gray diagram is showing the total car manufactured, whereas the red line is showing the cars which are able to run on ethanol. So it's clearly the manufacturers are increasing the car manufacturing which are based on ethanol as a fuel. In 1930, Brazil's ethanol industry started, where government directed sugarcane into ethanol production, and they have made addition of ethanol to gasoline compulsory. In 1973, international oil crisis doubled Brazil's expenditure on oil imports. Government was forced to consider alternative sources of energy to decrease its dependency and spending on fossil fuels. In 1975, increased ethanol production as a substitute for gasoline. They invested in increasing agricultural production, modernizing and expanding distilleries. They have established new production plants, introduced subsidies to lower prices, and reduced taxes for ethanol producers. Over 15 years, production of ethanol escalated from zero point 0.6 billion liters to in 1975 to 11 billion liters in 1990s. Further progress have been made with bioethanol establishments. In the period 1975 to 1978, 1 part of ethanol was added to 4 parts of gasoline. Additionally, processing stage to remove water from the fuels. After 1978, production streamlined to focus on hydrous ethanol. Ethanol which contains 5% water that could be used in cars fueled entirely by ethanol. Further, researchers have developed alloy to protect the internal parts of gasoline-powered engine and fuel tanks from corrosion by ethanol. In the period 1986 to 1989, 19% of all new vehicles sold in the domestic markets were ethanol fueled. But during this process of ethanol production, they have also faced some problems. The first and major problem was the waste generation. Vinage is a waste or a corrosive liquid byproducts of ethanol distillery. Being dumped in the rivers, this waste causes environmental damage. Bagasse were leftover sugarcane fibers, which were major concerns for the distilleries and plants. So, what are the solutions for this waste? So, interestingly, vinage was found to be a good fertilizer for the agriculture crops. So, transportation system was developed through combinations of trucks, pipes, and ducts to carry these vinages from distilleries to the fields. And bagasses were collected for the production of energy, and these bagasses were uh, power steamed into turbine for electricity generations and other purposes. So more energy could be produced, allowing ethanol plants to become more autonomous in terms of energy contributions. The factor is to keep ethanol production cost very low. Then what are the social impacts? This ethanol production created jobs for locals mainly in the rural areas. Expansion in sugarcane cultivation may increase food prices. This would leave the poor with a harder survival. Also, the ethanol industry will greatly increase the wealth of the sugar and alcohol sectors industry. So students, let's now summarize what we have learned in this module. Alcohol production is an important fermentation because of the following reasons. First, the ethyl alcohol used for fuel consumption and industrial purposes. Also, ethyl alcohol gives byproducts like carbon dioxide, yeast, biomass and fertilizers which are there, have their various applications in the respective areas. This gives effective utilization of agro waste, for example molasses, sulfide waste, liquor. Ethanol is one of the best tools to fight vehicular pollution. It contains 35% oxygen that helps complete combustion of fuels and thus reduces harmful emissions. It also reduces particulate emissions that poses a health hazard. Overall, ethanol is a part of our nation's solutions to reducing our dependency on imported oil, creating domestic jobs, cleaning our environment by reducing dangerous emissions caused by burning gasoline, and helping to improve engine performance by adding high octane levels. Thank you.